Hi, and welcome back to another Save It for Parts gadget review. Today, we've got an EMF meter to play with. No, I haven't transitioned to a ghost hunting channel. I'm hoping this has some legitimate scientific-ish uses with some of my experiments, my radio projects, and maybe some other stuff around the house. So this is a sponsored review of the Olmlmo EMF Meter. I'm never quite sure how to pronounce some of these company names. And this is apparently an electromagnetic field measurement device. Alright, so we've got our little main unit, the EMM02 charging cable and manual. So the manual on this is a little vague. It has some very helpful instructions here, like these are the buttons. Yeah, it gives you a little bit of information about it. It talks about measuring electric field intensity, magnetic field strength, and RF strength. I'm not 100% sure what all of these things indicate, so we're going to have to do some research on this probably in addition to the little manual, because this is pretty basic. Oh, that worked well. Can't get the little screen protector off because the tab here just popped off of it. So the different modes here are electric field intensity is this button. I think that's what we've started on. So we've got volts per meter. So this is kind of like the little beepers you use if you're trying to find a live outlet or find your wiring in the wall or something. All right, well, we can confirm that there is electricity in this outlet. So our next mode is W-elect, or weighted electric response. Okay, I don't actually know what that is or how to read it. The manual is pretty vague on that. Let's just skip over to mag, and that gives us apparently the magnetic field strength. So nothing particularly magnetic right here. Nothing magnetic over there. All right, let's try it next to an actual magnet. Looks like it's most sensitive up here at the front, and it seems like it has to be a pretty strong magnet. These little flat fridge magnets don't get picked up at all on this thing. And then our third mode is RF, or radio frequency. So that changes our display to, I believe, milliwatts per square meter. And we've got nothing in this room here. Let's see what it does with a cell phone. Now, if you get tired of all the beeping, you can hit the power button here, just a short press, and that turns off the alarm. So according to the meter here, Donnie seems to have some RF radiation coming from his head, and for some reason it only works with Donnie. Apparently one use for these is to test the safety of your microwave oven. Okay, we've got it in RF mode, and we're just going to start the microwave. Alright, we're definitely getting some kind of radio frequency radiation right around the microwave here. I'm also going to try the peak mode, which apparently measures the RF for about 5 seconds and then shows us the maximum during that time. Well, with that mode, we're getting RF from the microwave when it's not even on. It also doesn't seem to have very consistent numbers. Sometimes it's 0.5 milliwatts, sometimes it's up to 1 milliwatt, right in the same area here. Now it's down to 0.2 milliwatts. So it definitely does measure RF, but it doesn't seem to be super sensitive at any distance. For example, I have to get basically into the same closet as the Wi-Fi router before it picks that up. Now, I was kind of curious about plain old static electricity, the kind you get from a dry day, from your cat, from a balloon rubbing on your hair. And we're definitely detecting static electricity. I can get it to alarm just by rubbing a balloon on my hair from 18 inches away from the meter. So I think personally I would take the alarm setting on the electric meter with a grain of salt. Unless you have a really poorly designed pacemaker, I don't think anyone's getting negative health effects from static electricity. So having this thing sound an alarm for something this simple that you encounter every day doesn't give me a lot of confidence in its ability to warn you about other potential dangers. Well, so far, I think I've proven that the microwave is haunted and the cat is giving me cancer, or that I just don't know how to use this thing properly. It seems pretty subjective. It seems like you can get it to read almost anything you want depending on how you hold it, where you hold it, and I'm going to need to do some actual research to find out what is this thing telling me, how do I actually use it, and what do I do with the information that I get from it. I did some online research and I found quite a few papers studying EMF radiation, studying RF fields, studying the effects of magnetic fields. I couldn't find anything really conclusive about health effects, at least not in a major scale. Now, I wasn't able to find too much information on how to properly or reliably use one of these devices. Most of the how-to guides I could find online were from ghost hunters or conspiracy theorists or other unreliable sources. So I didn't find a really good guide on how I'm supposed to use this thing and how I'm supposed to interpret the readings. So I've come up with kind of my own test regimen for it. I'm going to set the meter at a specific location, a specific distance, and give it some sources to read without me holding it, because one thing I read was holding it close to your body or holding it close to the cat, as I was doing earlier, will actually reflect electromagnetic fields, radio wave fields from other sources. So if you hold it wrong, basically you're going to get completely the wrong reading. First up, we are bringing a cell phone in. We are at 0 on our electric field, and we get about 25 to 30 with the cell phone right in front of the unit. For magnetic field, we're starting at 0, and we're getting 0 with the cell phone next to it. For RF, we're starting at 0. Let's see what happens if I have a video playing so the cell phone is using data. We'll bring that close to the meter. We're actually not getting much still. That's with Wi-Fi. Let's turn Wi-Fi off and try 5G data. Playing a video so we know it's downloading data. And now we're getting something. We're getting that alarm level on the RF setting about a foot away from the cell phone. And right up close to the meter, the phone seems to be putting out somewhere between 2 and 4 milliwatts per square meter. While we're on the topic of RF, let's look at some other common household radio sources. First up, I've got one of those little cheapo FRS radios that everyone uses to talk to their kids at the mall and whatnot. So that jumped up to about 4 milliwatts per meter squared, even about a foot away from the device. Okay, so our little $10 radio here actually maxes out the RF on that meter. So this little thing that probably every kid has in their toy box is far, far more powerful in raw RF output than a given 5G cell phone. Let's try an older radio. We've got a Citizens Band handheld from probably the 1980s that takes about 1,000 AA batteries. Now this one is also maxing out the unit, but it's doing it pretty inconsistently. It kind of goes from 0 to max within just the space of a few inches. Possibly because this is using AM frequencies rather than FM like most other things. I'm not 100% sure how this little guy deals with AM versus FM. Then we'll try a little VHF Marine handheld. This is very similar to what you'd be using if you were working on a construction site or on a boat or as a security guard. Wow, that thing maxes it out over a foot away. Now, obviously, all our devices here are using different frequencies. The phone is probably using up near the microwave band. The FRS radio is like 400 megahertz. The VHF radio is around 150 megahertz. And the CB is like 27 megahertz. When it comes to exposure to pure RF power, you're getting more exposure from your job site radio, from your boat radio, probably from any construction site or security guard you pass than from your cell phone. And you're actually getting more exposure from your little mall walkie-talkie than you are from your cell phone. Let's go back to electrical fields for a moment. Let's take a look at a hairdryer. That has a large electric heater in it. It has a motor for the fan. That should put out some electrical and magnetic fields. All right, so we definitely have an electrical field strong enough to set off this thing's alarm. Let's try the magnetic setting. We actually maxed it out there by holding it up close. So again, if you're actually worried about electromagnetic fields for health reasons, one of these things is pumping a bunch of them right into your head. We've got some more of these fridge magnets. Even though these will stick to metal, they have no detectable magnetic field by this little meter. These neodymium magnets, on the other hand, do have enough of a field to set the meter off. So this video isn't about the accuracy of government reports or about the safety of electromagnetic fields or RF radiation, but I hope I've shown that various things around your house can have more RF radiation than, say, your cell phone or other things that people say are dangerous. What you do with that information is up to you. Before I wrap up this video, I have one more thing I want to try with this. I've heard that one of the legitimate uses for these is to test Faraday cages. Now, a Faraday cage is a grounded, basically metallic box or screened box of some sort that prevents radio waves from going through. So this is our catio. It has 4 sides made of metal screen and metal chicken wire. The bottom is the ground, and the back wall against the house is actually pretty RF opaque as well. Our house is filled with rebar and metal mesh and all kinds of stuff in there. When it was built, they thought the Cold War was going to heat up, so they made this house pretty bomb-proof. First up is our FRS mall walkie-talkie. So our Faraday cage does not seem to be opaque to UHF 450 megahertz. We're actually getting a little bit of CB traffic. I didn't know anyone still used CBs. Seems like somebody's transmitting pirate music on here. And I expect we'll have no trouble with our Marine VHF radio, so I'm gonna actually go clear across the yard. All right, so that's still alarmed with me a good 20-30 feet away. So the Olmlmo EMF detector has been a fun little gadget to play with. We were able to learn some things about EMF radiation. We were able to try out some experiments. We discovered that the catio is not in fact a Faraday cage, even though some commenters on the YouTube channel thought it might be. Thanks again to Olmlmo for sending me this little thing for review. If you'd like to buy one for yourself, I will put all the links in the description down below. I'll also include some more information about electromagnetic fields and RF fields and other stuff that you can learn about. I hope this has been an interesting review for everyone. Thanks for watching, and we'll see you next time.